vMotion and cold migrations, or otherwise known as migrations, both cold and hot. So one of the reasons why you've probably bought your ESX infrastructure has to do with the fact that as you move towards the data center level version of VMware, this ESX virtual infrastructure thing, you get this ability to do vMotioning or migration of machines across multiple platforms. And really that's one of the most compelling reasons to spend all that extra money to move into the enterprise level version of VMware ESX. When we talk about migrations, we talk about migrations both cold and hot because there's a difference based on whether or not the machine is powered on or powered off. If a system is powered off, we call that a cold migration. The system's down, and in fact, doing a cold migration is much easier to do from a technical standpoint than it is from doing when it's powered on. Obviously, if the machine's powered on, we have to move that state information over, and so the machine doesn't lose any information as it's going across from machine to machine. In this nugget, we're going to talk about deploying machines as opposed to migrating machines. And in the last nugget, we talked, the process of deploying a machine involves cloning, it involves building a new machine from scratch, it involves creating templates, but really this is about moving existing machines from host to host. We're going to talk about in this nugget the process of doing both cold and hot migrations, and vMotion and hot migrations are both equivalent terms that we can use, and also some concerns and gotchas associated with the process of doing migrations. Now I want to show you a picture first of all, just to talk about the difference between a cold and a hot migration. First of all, let's divide our little piece of paper here in half, and we'll put cold on the left, and then we'll put hot on the right. And this is the vMotion idea. When we're doing cold migrations, typically we have our ESX server here, and maybe we've got another ESX server over here. And what we're looking to do really is take our data store, and then there's our slice out of our data store, and here's our connection into that slice. We have our virtual machine that's sitting here in our data store, and that machine is powered off. And when that machine is powered off, we can migrate that machine from chassis to chassis. So really with cold migrations, there are a couple of different things we can do. Number one, we can take that virtual machine here inside of this data store and then transfer the ownership of it, the host that is actually running the machine, from here over to here. And that's one form of doing a cold migration. We're going to say, okay, we're going to let this other host actually operate starting at now. We're going to go, okay, you're going to operate this machine starting now. The other thing we can do is maybe we have another slice of our data store. We want to move that machine over to a different slice. That's another way we can do a cold migration, is actually migrating the data files of a machine from one slice to another, or maybe even to a different data store if we want. If we need to migrate to another data store completely, we can do that. Now, migrating to a completely different data store between data stores can only be done when the machine's powered off. So that's only the only way we can do a cold migration. However, sometimes we want to be able to do these migrations while the machine's powered on, and that's this hot migration. So if we bring back our, whoa, those are really bad. If we bring back our data store diagram here, and we do our little slice, and here's our virtual machine, and here's our ESX box over on one side and ESX box on the other. In the hot migration standpoint, what we're actually doing is just the transfer of the ownership of that virtual machine from one host to the other. Now, what's actually occurring? There's really no data movement that's going on whenever we do that transfer. If we're doing that transfer, what we're transferring is just what's actually occupying the processor, what's actually manipulating the bits associated in our data store there. And so the reason why vMotion works and why it works without actually dropping too many ping packets or losing any transactions in your database is because there's really no data that's being moved. Instead, we really kind of snapshot the existing processes that are going on the source. We transfer over the necessary needed bits onto the target, and then we relinquish control from source to target. And at the same time, we have some networking components that need to be updated. We have some routing that needs to be changed on our network side. But for the most part, the reason why vMotion works is because not a lot actually moves from host to host. So when we talk about cold migrations and when we talk about hot migrations, you'll see that there are some options in both that are different. So let's actually leave this picture now, and let's go into our virtual center, our virtual infrastructure client, and take a look at how we can do cold migrations and how we can do hot migrations. Now you'll see here inside of the virtual infrastructure client, we have one host here. The other host that we generated in our last nugget, we've actually cleared out. So we can take a look at just this nugget one and how we would move this nugget one from host to host. First of all, you'll see that nugget one is currently powered off. And so what we're going to do is complete a migration to a new host, a cold migration. We can either click this link or we can right click up here and choose migrate. If we choose the migrate tab, the very first thing we're going to see is a wizard that is going to do some configuration for us. Whenever we choose the destination host that we want to send our machine over to, it's going to perform a sense of validation. It's going to validate whether or not that destination machine can actually handle the virtual machine. If it's got the right configuration, if it's got the right processor class, if it's really ready to be able to handle that. And there's a number of tests that occur as part of that validation. Once we've clicked into our new host and we choose next, we can choose the resource pool associated with that new host. We'll talk about resource pools in a little later on when we talk about clusters and resource pools and DRS. Once we have our resource pool configured, then we need to choose a data store that we can put that machine into. Now, this is the concept that we talked about before about how there are multiple different kinds of cold migrations that can occur. We have the ability of keeping it inside of the same data store, or we can move to a new data store if we want to as part of our cold migration. And that's what we're doing here inside of our this step in our virtual machine wizard. The first option says keep virtual machine configuration files and virtual disks in their current locations. And the second step says move those to a new location. In this first test, let's actually keep them in their current location. So we just transfer control of that machine over to our second host. Now you'll see here that the new host is going to be the location where this machine is being run. If we click Finish, the process of moving that machine over actually happens extremely fast. A cold migration where we're not actually moving any bits goes by pretty fast, actually. Nugget 1 is now being owned by 102. You'll see that the process of relocating some of the bits of this are being queued up, and in a minute we'll actually see the increase of the status as it goes to 100%. But really, the transferring of the ownership of that virtual machine from one host to the other doesn't take a lot of time because, again, there's not a lot of data that has to get manipulated. If, however, we didn't want to not only move the control of the machine from one place to other, but we wanted to move also the files that comprise that machine, we can do that as well. Again, with the machine powered off, we can click the Migrate to New Host button and begin that process again. Let's say I want to move that machine back to 101. But in addition to moving that machine back to 101, I also want to migrate the virtual machine files as well. If I go back here and click Next, and then I choose Move Virtual Machine Configuration Files and Virtual Disk, you'll see now that I have the option of choosing whether or not I want to send it to maybe a local storage or to an NFS storage that we've created, or the original data store. If I click the Advanced button down here, I additionally, like before, have the ability to change the location where my configuration files as opposed to my hard disks go. Now, we talked about this before, but because of that block size, because the block sizes are so large and our configuration file sizes are so small, we can actually we can separate out the configuration files from the hard disks because we want to put those on a different kind of storage. It doesn't have such large block size, for example. You'd do this if you're particularly squeezed for storage on your data store. So if we don't have need for that, we can choose a different location to move our data files into. Maybe we want to move it to NFS storage, for example. And that will not only relocate the virtual machine, so it's owned by a different host, but it will relocate the virtual machine files, so those virtual machine files are now stored on NFS storage. I'm actually going to cancel out of this because I don't want to move this system over to NFS storage because, as you remember, NFS storage is a lower performing type of storage. But that is the process to do a cold migration while we're relocating VM files. Now, there are a couple of things to know about this concept of cold migrations and even hot migrations. And it has to do with, first of all, the concept of the data center. You see here we created this Nugget data center up here at the top level. The data center really is the boundary of these migration capabilities. And if you try, you won't actually be able to migrate between data centers. So if you try to go here and migrate to a new host and migrate to a different data center, you're going to get an error message that says, I'm sorry, you're not going to be able to migrate from data center to data center. So think of your data center as the ultimate boundary of your infrastructure. Secondly, there's another thing you need to be aware of too, and that's if you right click here on this host and you see this tab for relocate VM files, that actually does less than what I think you probably think it's going to do. When you click the relocate VM files, you'll see that it goes up and it queues up and it's doing some relocation of virtual machine disks. What this is doing is essentially consolidating the configuration files from the disk files. And if you have configuration files that are sitting out on the host, like in non-shared storage, and the disk files that are sitting in shared storage, it'll combine the two of these so that they're all in one location. Now, this may be something you want to do if you've just recently done a migration from an earlier version of VMware, ESX, or if you've moved those into different locations. But really, this concept of relocate VM files is not the process of vMotioning or the process of cold migration. It has something has to do with something completely different. So this is the process of cold migration. The next thing I want to do is really power on this machine. And once this machine is powered on, we're going to talk a little bit about how we can do a hot migration, which is the process of moving that machine while it's still powered on. Once that virtual machine is powered on, we can move it around across the different hosts inside of our data center through that vMotion capability. Now, the very first thing you're going to learn is once this machine is powered on and we get to our status of complete, you'll see that the arrow is started here, and if we go to our console, we'll see that the virtual machine is completely powered on. There's a couple of things that have to occur before a successful vMotion can complete. Number one, the VMware tools have to be installed inside of the virtual machine. And the VMware tools actually have a heartbeat that occurs between the server and the virtual center server, and the virtual machine itself that allows that machine to communicate so that the vMotioning process knows that that machine is up and running. And that heartbeat has to actually be occurring so that the vMotion can complete. If you attempt to vMotion a machine before it completes enough heartbeats to fulfill the requirements of the virtual infrastructure client and the virtual center server, you're going to get an error message. There you'll see that our machine has completed the power on process, and in a minute here we'll actually see the BIOS screen. What I want to show you here now is if I right click and choose the migrate button, it's going to ask us, okay, if we want to migrate back to 101, it's going to complete the validation now, and an error message is going to occur. That error message says, okay, we're attempting to migrate from 0.102, and no guest OS heartbeats are being received. Either the guest OS is not responding or the tools are not configured properly. So what this says is that you're not actually going to be able to complete a successful vMotion until you have that heartbeat. So once you power on a machine, make sure you give it a little bit of time for it to completely come up and for those VM tools to complete before you attempt to do a vMotion. So let me go ahead and click cancel here, and I'm going to pause the recording while we wait for Nugget 1 to complete its power on cycle. And when we come back, we'll show you what the process is, and it's very, very simple, similar to what we've already seen. And we're back. You'll see here that our Windows Server 2003 instance is now powered on, and we have a successful boot of our Nugget 1 system. What I want to do now is actually migrate this host from this VM from one host to the other. But before I do that, actually, I want to bring up a little command prompt window here, and I want to type in ping-t nugget 1 so we can watch and validate to see how many pings that we actually lose during the process of migrating this machine from one host to the other. Let's go ahead and right-click on Nugget 1 here and choose Migrate. And then in this case, we're doing a hot migration, so we have to do the validation just like we did before, and we'll see, yes, our validation has indeed succeeded. We can click Next, and in this case, we are not going to be given the option to change the location where those VMware files will be hosted at. Instead, we'll be given this opportunity to choose what sort of priority we want to choose for our vMotion. In the case of high priority, resources are reserved on both the source and destination hosts so that that virtual machine will be continuously maintained during the migration. And what this says is that we want to make sure that at no point during this migration will our virtual machine actually lose connectivity with the rest of the network. If we choose a low priority, that has a better chance of succeeding, meaning that the vMotion has a better chance of actually occurring, but there is a chance that there may become a brief moment of unavailability if the sufficient host resources are unavailable. So be aware that if you're doing these migrations, and it is very important for that machine not to go down or not to lose any sorts of ping packets whatsoever, you're going to want to choose a high priority migration over a low priority migration. Even with the high priority migration, you may still lose a couple of ping packets, but generally that's a small enough amount of window that most services have a timeout window, and that it's going to be less than that timeout timeout window for most services. So then we click next here, and then it says we're ready to complete, and this is going to be a high priority vMotion. And as soon as I click finish here, I'm going to bring up that command prompt again. We're going to watch the process of this system as it vMotions from one host to the other. You'll see here we're completing our ping process, and the virtual machine is now migrating. Now, one thing you need to know about this migration process is that it can actually take a pretty decent amount of time, because there's a certain amount of stuff that needs to occur for the vMotion to happen. There's a little bit of files that have to get transferred over, and obviously that current state of the system has to get transferred over, so it's a seamless move from one host to the other. What we're seeing here now is the progress of the transferring of that state information from one to the other, and the synchronizing of that state information from the source to the target. So this process sometimes takes, I don't know, a vMotion can take sometimes a couple of minutes, sometimes 2 or 3 minutes to complete, depending on, number one, how much change, the rate of change that's going on in the virtual machine. In this case, our Nugget 1 isn't not particularly hit, because it's up and running, but there's nobody actually doing anything to it at this point. Another thing that can impact the amount of time it takes to do a vMotion is the relative use of the ESX servers that you're using. These ESX servers are running inside of Workstation, and so obviously there's some virtualization overhead which reduces their effective performance. So the process of completing the migration can take just a little bit longer, because these are lower performing systems. You'll see here now that we're about 94%, and we've lost a single ping packet right there at the 90% time frame. And generally right around that 90% time frame is when the real meat of the movement really occurs. And when you hit 90%, that's when you're going to see any kind of ping packets getting lost right there. So we've completed a successful vMotion, and we've only lost one ping packet in the process of actually moving that over, even considering how not very well equipped these ESX servers are. They're hosted in Workstation 6, and so they're not really high performance servers. So even on a low performing server, we can still manage to do a successful vMotion and only lose a single ping packet. And that's pretty impressive in my book. One thing that you do need to know whenever you're completing this vMotion process is that there are differences between the different processor classes of all the systems in your environment. And vMotion is very, very intolerant of systems that are not the same. And the reason for that is because there are different processor, we'll call them feature sets, based on different types of processors. Number one rule is that of AMD and Intel processors, you'll never be able to vMotion back and forth between AMD and Intel processors, at least with today's technology. Within the processor manufacturer, if you try to go more than a few processor classes or steppings between them, you're also going to have problems. So it's important to know whenever you're building out your ESX environment that you build machines and you create machines that are relatively similar to each other. Because if you try to do it against disparate machines, sometimes the vMotion process won't work. Generally, the cold migration always works, but the hot migration is the part that sometimes has issues. If we right-click on the virtual machine and click Edit Settings here, and we go over to the Options tab and choose Advanced, you'll see here this CPU identification mask. What this is a particular bit, a particular feature set bit that can actually be disabled to allow more compatibility of vMotion between different hosts. So if you have different hosts that have this NX flag, and this NX flag here is the processor feature set that actually enables this concept of DEP, or data execution prevention, that you'll see inside of Windows if you right-click on My Computer and choose Properties. But hiding that NX flag actually enables more vMotion compatibility between hosts. But there's performance feature sets that are going to be disabled by doing that. So you can actually choose to hide the NX flag from the guest if you are having problems actually doing vMotioning. And you'll know you have those problems with vMotioning because as it attempts to do that validation, you'll get an error message in for vMotioning. Now there's another thing you can do as well, and that's click the Advanced button here. And you'll see here that in our Advanced button, we have a number of different options for adding in masking bits, for masking out certain processor feature sets based on different disparate processors. And we're getting a little bit out of scope for what we can talk about in this nugget. And then none of this is actually supported by VMware. But if you actually get an error message when you're doing the validation, the pre-vMotion validation that says you're having problems with various register sets and various levels there's incompatibility between those register sets, it is entirely feasible for you to go to this virtual machine default identification mask and add in masking out information and putting zeros in here to say, okay, we want to mask out these particular feature sets. So again, this is way out of scope for this particular nugget, but there is a capability in there unsupported by VMware to enable vMotioning across very disparate processor sets and processor classes. When you go and actually buy your hardware, your HP or your Dell hardware, your IBM hardware that you'll be using to host your ESX instances, make sure that you double check with VMware or check their hardware compatibility list to make sure that the different processor classes you choose and the different chassis types that you choose have the ability to vMotion between each other. Or you may end up with isolated islands, if you will, of vMotion capability amongst the servers inside of your data center. So be aware of that. And there are actually PDF documents out on the web that will tell you for this HP system and this Dell system, or this HP system, this HP system, will they be able to vMotion against each other? And you must check that before you purchase any hardware for your environment. And then that's doubly so if you end up adding any hardware in later on, so you don't end up with those vMotion islands. So what have we talked about today? We've gone into sort of the introduction of vMotion and cold migrations and how you can do migrations back and forth between systems. We talked about how this is not really deploying machines. This is taking existing machines and moving them around inside of our infrastructure. We talked about cold migrations and how that involves not only moving the ownership of a virtual machine from one system to the other, but also relocating those VM files if necessary. And we showed that really nifty vMotion capability. We're going to expand our vMotion knowledge when we talk about DRS, distributed resource scheduling, and also high availability, where we can put some management logic surrounding this vMotion capability and turn it into something that is very useful for us. And then we also talked about some of the concerns and gotchas associated with those processor classes and how you have to be very careful with how you purchase equipment so that you don't have problems with this vMotion or create these islands of vMotion capability. I hope this has been informative for you, and I'd like to thank you for viewing.